Okay, let us discuss again the following problem. So let G be a group and the cardinality of G is even. We would like to show that there is an element A in G such that A squared is the neutral element. So actually the idea is rather simple. So this is the idea. So let's say we have this G. Okay. And take any element X in G. Okay. According to the definition of group, then this X has an inverse. And let's call that inverse to be X inverse. Okay, so we have this as a pair. Okay. And then after we make that pair, we look at another element outside of that pair. Let's say Y. And then look at also with its inverse. Okay. Keep doing that. So then G will be the union of X and X inverse, something like this. Yeah. Where X run through a certain, I don't know, a certain index, a certain set, something like that. Okay. So that's basically the idea. And then among this thing, okay, when X, remember that G has a neutral element, the neutral element. When X equaled the neutral element, then this set, which is E, and the inverse of E, but the inverse of E is itself. The inverse of the neutral element is itself. So in fact, this is a singleton. Right? This is a singleton. Okay. So then basically we can separate G as the singleton union with, let's say, T prime, for example, X inverse. Okay. So now, if none of this is singleton for any X in T prime, it means the cardinality of G will be 1, and each of this guy is not a singleton, so it has two elements. Therefore, the number of elements of G is 1 plus twice of the cardinality of T prime, since each of this set consists of two elements. So it means the cardinality of G is odd, and that contradicts with the given information that the cardinality of G is even. Okay, so that is basically the idea. Now let's try to be a little bit more formal. So say gonna prove. So all the above things are just some elementary analysis in order to have a nice argument. We try to learn a rigorous argument. So first we can say that consider or note that G is contained in the union of X in G, X inverse. Okay, why is that so? Since for Y in G, because we list all elements in G as the first member of that set, then of course Y is appear in the set consists of X and X inverse. Since for Y in G, then Y is in y inverse, definitely. Okay, so this is a true statement. Okay, but there are some redundancy. For example, if we take x and x inverse, okay, so for x inverse in G, the sets x inverse and x inverse inverse, they are actually the same. They are actually the same set, are the same. Okay, so then whenever we have that kind of redundancy, then we can drop one of them. Okay, so then we can say that by dropping redundancy, okay, there is T subset of G such that G, so first of all, if G is contained in this guy, but each of this guy is also contained in G, so saying that G is contained in the union is also implies that G is exactly equal to that union. Okay. So now by dropping some of the same set, we can make the union still equal to G, but we don't really need to take all x from G. We just need to take x from T, from a certain T, such that x inverse, the intersection between x inverse and y inverse is empty set for x, y in T. Okay, so we can have that kind of T, right? Do you agree with that? Okay, so now we basically follow the same idea. Write G as E, so when x is equal to E, so since E is element of G, then there is this kind of set that contain G, or in particular the neutral element is contained in E inverse, which is exactly just a singleton. Okay, so the G is equal to E union x in T without E x inverse. Okay, now since all the x inverse are disjoint, then the cardinality of G is, so I need to say that suppose on the contrary that there is no A in G, A not equal to E. So I need to fix a little bit the problem, because certainly if A is equal to the neutral element, this equality satisfies right away. So in order to make the problem more interesting, when there is A in G, A is not the neutral element such that a squared equal to e. Okay, so let's say there is no such a in G which is not a neutral element such that a squared equals e. Okay, so what does it mean? It means that hence x inverse or a inverse. So saying that a squared equals to e is the same thing as saying that the inverse of a is itself. So it means that there is no a such that a inverse equals a. Hence a inverse not equal to a for all a not equal to e. Thus x inverse, its cardinality is equal to 2 for all x not equal to the identity. Okay, so now we can count how many elements of G. So the number of elements of G is 1 plus each of these are disjoint and each of that consists of 2 elements. So therefore the number of elements in the union is just twice of the index of this, twice of the cardinality of the set T minus E. Okay, which is an odd number. But this is a contradiction. Okay, so therefore what is wrong? What's wrong is that we assume there is no a in G such that there is no a in G which is not a neutral element such that a squared equals to e. So that cannot be true. Therefore, there is a is not a neutral element such that a squared equals e. And so we are done. Okay, so that's all for now. Thank you very much for watching. See you again in the next video. Bye bye.